already we studied. That is with the help of entropy, we can determine. Okay, and now the second one we are going for that one. That is the Gibbs free energy. So if you talk about Gibbs free energy, there is the Gibbs free energy. Last class, something we did study about this one, Gibbs free energy. Gibbs free energy is also, that is what that is useful energy. How we define the Gibbs free energy? If you talk about, so it is useful energy. It is useful energy. We are talking about. It is useful energy. No, or you can say,
Yeah.
or the energy used to do useful work. No? That is also the definition is there. Energy used to do what? Useful work. That is also the definition, useful work. This is what the definition. Now their point, what they are saying, Gibbs free energy, they are talking about. If you see, that is delta G, it is representation is there. If it is that is, if it is, it can be the standard also. This can be standard also. So if it is standard means we have to put the not. So there is the three value is possible for this one. Suppose it is coming the case one, it is coming the negative. Delta G value is coming negative. So if it is negative is indicating a spontaneous process. A spontaneous process means that is feasible. That you can say that is reaction or the process feasible. Reaction feasible. This is the what the point. Okay. Now if we talk about the positive value, positive. So it is going. It is saying that is non-spontaneous. It is not going to be spontaneous. It is non-spontaneous. Okay. Means
Okay.
that is thermodynamically not feasible, you can say. So that is simple is the non-spontaneous. Now the last one is that it can be the zero. Okay, and zero indicating what you can say, that is equilibrium condition. That is reaction is at the equilibrium state, equilibrium condition, right? Now if you talk about the last day I told you this one, that is the equation. What is the equation is there? Gibbs Helmholtz equation. Gibbs Helmholtz, Gibbs Helmholtz equation. This is there in your book. So what is this equation is saying? Delta G naught is equal to delta H naught minus T delta S naught. Okay, these are the
Yeah.
quantities. Okay, now here the point which we have to, delta means difference. Delta, wherever the delta is there, this is going to be the difference. Okay, there are so many equations are there, but this is the first equation. Okay, in the very first equation I am writing, if you talk about delta S, what do you mean by delta S here? So delta S not is equal to S not product, S not product minus the product minus what will write, that is S not reactant. That is we did in the last class, S not product. Similarly, delta H is the change in energy or enthalpy. So also we can write delta H naught, which is going to be product. Okay, here delta sign are there. Minus that is delta H naught reactant. Okay, this one is there. This is the formula number one. If you are talking about the another formula, formula number two, what can be? So delta G naught is equal to delta G naught product. Here it can also be there. Delta G naught product minus delta G naught reactant. This is the second one. This is the second formula for the calculating Gibbs free energy. One is that is delta H minus T delta S. Second one is what? Delta G naught minus the react product minus delta G naught reactant. And delta H you know already, delta H product minus delta H reactant. Delta S naught you know, delta S naught product minus reactant. The third equation is also there. Can I reach? Can I go on the next page?
Yeah.
So that is the third formula is also there. Delta G is equal to delta G is equal to delta G naught, delta G naught plus 2.303 RT log, Kc, RT log Kc, or you can say Kc, or it can be Qc also. Okay, the point which we need to keep in mind here, that this equation can be also written as what? Because ln is equal to what? That is 2.303 log. log base 10. So that is ln. If you are writing in the form of that is here is log base 10 is there. But if it is natural logarithm is there, so it is going to be delta G naught plus. You can write that is RT ln KC, or you can write that is QC. Okay. So 2.303 is the conversion factor, right? Yes or no?
Right. Yeah.
Okay. Now the another point at equilibrium. At equilibrium. If we talk about at equilibrium, which formula we are going to apply? So at equilibrium, delta G, no, at equilibrium, what the point is there? Here I'm writing at equilibrium, delta G is equal to 0. Delta G not now, delta G is also 0. At equilibrium, delta G is equal to 0. So if delta G is equal to 0, so here we can put out the 0 in the equation third. So here is 0 is equal to what is coming? Delta G naught plus 2.303 RT log base 10 Kc, or that is going to be QC. So here delta, if I put delta G this side, so delta G naught is equal to minus 2.303 RT log base 10, it is going to be Kc, or that is going to be QC. Can you be able to understand this one equations?
Yes.
Okay, thank you very much. So let us try to solve the problem based on this, all the three formula all together. I mention you for the Gibbs free energy, delta G is equal to delta G naught is equal to delta H minus T delta S. Second one, this is the Helmholtz equation. Second one is delta G naught product minus reactant for the reaction. Delta S last class you study product minus reactant. Delta H also last class I think over delta H product minus reactant. So we are going to solve. Can I erase this one?
Yes.
Thank you. So here I am writing the questions. Calculate, they are talking about calculate the value of delta G naught for following reaction. Delta G naught for following reaction. Okay, delta G naught for following reaction. What are there? That is carbon solid, okay, plus oxygen gas, they are going to be CO2. Okay, for this reaction, they are talking about for this reaction, what some information given. For this reaction, delta H naught is minus 393.5 kilojoule, and delta S naught is 3.05 joule. Here you see the unit, you see kilojoule, and here is joule per Kelvin. At 298 Kelvin. At they are talking about at 298 Kelvin. So they are talking about delta G naught value. So here you see delta H and delta S are given. So what the equation we need to use, that is delta G naught is equal to delta H naught minus T delta S.
T delta S.
So here if you solve it, talk about the delta, this is the minus 393.5. Then temperature they have given 298 Kelvin. So I am mentioning 298. Then again the no T delta S. If you are talking about delta S, so delta S also given, but here is 3.05 joule Kelvin is there, joule Kelvin. So if you want to put in the what formula, that is kilojoule, because here is the kilojoule. So what we need to do, we need to divide by 1000. Yes, yeah,
1000.
Yeah. So let us try to solve it out how much is coming. See, these all are going to be, here is negative or not there. They are positive, so all will become negative. So minus 393.5 minus, if you multiply this one, so it is coming 298 multiplied by 3.05. So
this is negative 394.54.
394.4 they have given kilojoule, kilojoule per mole CO2. But they are saying that is whether the process is CO2. They are talking about the process will be spontaneous or non-spontaneous. What you will say? This is the negative is coming. The process is spontaneous or non-spontaneous?
The process is spontaneous because delta G is negative.
Thank you very much. So that is spontaneous, means thermodynamically feasible, a spontaneous process.
Sir, could you excuse me for 1 minute? I'm just going to go get some water.
Yeah, no issue, no issue.
Sorry, sir. Thank you for waiting.
Yeah. So I'm erasing. Can I erase this one?
Yes.
So let us try to write down another problem here. What is the problem they are saying? Calculate delta G naught for following equation. So calculate delta G naught. Now calculate delta G naught for following equation. What are the, with the help of that is what the information we need to apply the formula. Okay, so they are talking about 2CH3OH, this is going to be gas, plus 3O2, this is again going to be gas. Here they are talking about 2CO2 gas plus 4H2O liquid, and some of the information they have given. What information they have given? Here is the substance they have given, substance, and that is delta G naught. Delta G naught they have also given, but the delta G naught given in form that is kilojoule per mole. Here is kilojoule per mole. So if I will write that is CH3OH, this molecule they have given, it is the value 163. And if we talk about O2, it is going to be 0. If we talk about CO2, it is 394. And if it is the H2O, it is going to be minus 229. Okay, kilojoule per mole. So they are asking to find out the delta G naught for the reaction. Okay, delta G naught. So option also, option if I will give, that is minus 1275 kilojoule per mole, means unit you need not to change. B number 1375, same unit. D, C number minus 1475, and D number minus 1575, and the unit are the remain the same. So what we are going to do, see, enthalpy of formation is there. So which of the which formula can we use? Can we use
We
this
can
one?
use the delta G product minus, yeah, reactant.
Thank you very much. So here we are going. So what we can write, delta G naught is equal to, we can write that is delta G summation of what delta G product minus summation of what delta G going to be reactant. This is the product and this is going to be reactant. These things we have to write. So delta G product means what? 2 into CO2 plus 4 into it is going to be H2O minus what we will write, that is 2 into CH3OH value plus 3 into O2 value. Is it okay to you to understand this one?
Yeah.
2 into CO2 column you can see minus 394 plus 4 into water column minus 229, and minus if you solve about this one 2 and into methyl alcohol CS 163, and then plus is there, plus what is there, this is the plus is there 3 into oxygen 0. Okay, this is there. So if you solve it out, how much is coming? Minus this is coming 788, something like that. And if you solve out this all, you solve, so minus 788 is coming, and you need to subtract how much if you are solving 329. So if you are solving, it is coming minus 1375, it is coming one. Check your answer, is it coming or what? Minus
1 second. I'm just
1375.
I'm getting a minus 1375.
Thank you very much. So this is quite okay. Let me give you, this is again going to be spontaneous only because negative value is coming. Okay.
Yes.
So I'm giving you one
If
more.
it's 0, then what happens?
Equilibrium. If it is zero, it means
Oh,
equilibrium.
equilibrium. Okay.
Uh,
Okay.
so means that is reactant and product are the interconverting equal rate. Okay, let me try to give you questions. Delta G not for uh, reaction they have given C2H4 plus H2O. This is C2H5 OH is there. Okay, what are the, here is the, if you talk about the substance, they are the substance, and here is the delta G naught value they have given kilojoule per mole. So they are asking here is, they are saying C2H5 if you are talking about, so its value they have given minus 175. And if you talk about H2O, okay, its value they have given minus 237. And last one is C2H4, so its value given 68. So they are asking delta G naught. Can you try? Can you try?
So this is going to be for C2H4 plus H2 C2H5. So C2. Is that negative 175?
Negative 170. Oh, no, negative 6 is coming.
No. I'm talking about the C2H5OH. Is the number
One,
a negative
yeah, yeah,
175?
minus 175.
Okay, so that will be minus 2. I got my answer to be negative 6.
Yeah, that is correct. Negative 6 and a spontaneous process.
Yeah.
Okay, okay. Little bit, can I give you little bit difficult one?
Yeah.
Okay. So I am giving you quite difficult. Okay. But taken from your book only. Okay. Taken from your book only. Okay. So yeah, I hope you will be, you can try easily. So here they are saying calculate. They are talking about calculate delta G naught for following reaction. Following reaction. So they are talking about 4Fe solid is there. Then they are talking about 3O2, it is going to be gas. So what they are saying, that is 2Fe2O3 is forming at temperature 298 Kelvin. Here they are talking about the what the data they have given, substance is there, delta H naught they have given, and but it is their kilojoule per mole. That unit you see, it is the kilojoule per mole, and delta S not also given, but it is there, they have given joule per Kelvin, joule, and here is kilojoule. So both are different. While solving the problem, you need to convert either kilojoule to joule or joule to kilojoule. Keep in mind, na.
Mm-hmm.
So here
Yeah.
is Fe2O3 is there. Here they have minus 82, no, 826 is there. Uh, 826. And other are there, if you are talking about, that is Fe, they are talking about 0. O2, they are talking about 0. Delta S, they are talking about 90. Here is the 27 and 205. So these many values they have given. Here this.
Mm-hmm.
Here is also this, and so
So calculate delta G for this.
so how
Okay,
can you do?
so first I know the equation for delta G is equal to negative or is equal to H minus T delta S.
Hmm.
Delta H minus T delta S. So by that I can find the G value of
Hmm.
Fe2O3
Hmm.
and
But directly you cannot calculate na single step. Step number one, what you will do? Step number one, you have to do delta H is equal to what is delta H, what not product, yes or no? Because delta H
oh
not
yes, product minus reactant.
delta H what that is going to be reactant. This is the first case. So here you can put. Then that is step number 2. What you need to do is step number 2, delta S. So delta S, that is means that is delta S, not that is product,
Product minus reactant.
delta S not a reactant. So these things I think we have done this last class. We have done this one.
Mm-hmm.
So should I solve or you are going to try?
I'll try it.
Okay, but you keep in mind the coefficient also here, coefficient.
Yes.
Okay, then try. Option is right.
So delta H is going to be negative 826 and 0. So delta H will be times 2, which is going to give me is negative 1652 kilojoules for delta H. And then delta S is going to be 180 minus 615 minus 108, so negative 553. So delta G will be delta H, which is 1652 minus 298 of 543. So this is going to be 1.5 times 10 to the power of 6 joules.
Yes. Delta G they are talking about, that is minus, you are talking about 1 point.
Yes, minus
1.49 into 10 to the power.
1.49.
Yeah, this is correct one. How fast you did, Surya? This much fast. First, one of the girls also I am teaching. She don't do anything, but that is very fast you did. Can I change the page now?
Yeah.
Okay, thank you very much. So here I am changing. I am changing the formula also because you are doing so fast, so that what I will give. If I will give again, you will within 5 seconds you will answer. Okay. But let us check. Let us see that is will you be able to do in 5 seconds or what? Again one question. Delta G not they are asking. It is faster. I'm writing. For that is the 2SO2 plus O2. They are talking about 2SO3. They are talking about here SO2 value. They have given SO2. Delta H naught and delta S naught they have given. This value is again going to be kilojoule and this value is going to be joule. Okay. So let's try to have a look over it. That is they are coming minus 297 and here is 248. If you talk about SO3, here the minus 396 and here is 257. And here is what is the talking about the it is O2. This is 0 and 205. So these are the value. Now they are asking. That is delta G. Now we start solving. Let's see. The same formula I think you need to use. Because the information is
so delta H is going to be 2 times negative 297 negative 297 plus so products minus reactant plus 0. So products, which is 2SO3, so SO3 is 2 times negative 396. And this is going to be minus 2 times. So this is 2 times negative 286, which is products minus reactant delta is equal to. And then what is the temperature?
temperature they have given here. Temperature 1 second. 290 is there. 290, 298 Kelvin only.
Minus 2 times SO2, which is times SO2, which is 248 plus plus 2, which is 2 negative 187. Delta H2 minus 2. Is the answer
minus 142.
is 142? 2 SO3, so 2 times 257. I messed up my calculations.
Delta H naught you can check minus 198 kilojoule. Is it
Yeah, I
coming?
got that. I got delta H to be negative 198 and delta H to be negative 187.
Hmm. Joule
Then where
Kelvin.
did I?
So,
I put in temperature wrong.
but you see, it is the Joule Kelvin is there. It is Joule Kelvin, and it is the kilojoule.
Mm-hmm. Oh, I have to convert joule
Delta
to
kilojoule.
mm-hmm.
Hmm. So here is delta G. If you are going, that is minus 142. Surely it will come in the form of kilojoule per mole. So this one you need to convert, divide by the 1000. So it will come, I think. Can we move to another one?
Yeah.
So okay, I'm writing the question and changing the formula also. So what the question they are talking about? Question they are saying calculate delta G naught for conversion of conversion of oxygen to ozone from following equation okay? From following equation. So conversion of oxygen to ozone from following equation. So if you talk about what is there, here is 3 by 2 O2 is there. This is the gas. It is converting into O3 gas, right? They are talking about 298 Kelvin, and if Kp value they have Kp for this is this reaction they are talking about how much they are talking 2.47 into 10 power minus 29. Okay, so and then they are asking how can you be able to do this?
Conversion of oxygen to ozone from the following reaction. Kp for this reaction is 2.4 times.
Temperature and these things given. Reaction is so means we have to apply delta G naught is equal to minus 2.3. R value also given. R is equal to 8.314.
8.31.
So 2.303. Then it will come RT log. We can write that is Kp. Kp value there, but 0.243 this value they have not given. So log, here you need to expand this one. Log 2.47 into 10 power minus 29. So this is fitting on the formula log A into B. Yes, no?
Yes.
So it is going to be log A plus log B, right? So if you, log A means it is going to be log 2.47 plus log that is 10 power minus 29.
Which is minus 29.
But you know very well log A power n is equal to what? N log A. Yes or no?
Yes.
N log A. So it is the log, you can write that is 2.47 minus 29 log, it is going to be 10. Yes or no?
Yeah.
Okay. So log 2.7 will be able to tell you, you solve this one. Just guess it out, the answer.
So this is log of 2.47. What is the log of 2.47?
Yeah, that we need to check out.
Log of 2.47. So that will be 0.39. And then we have So times R, which is 8.31 times T, which is T is going to be 390. Is the answer negative 71,814?
Again, please tell me. It is coming how much? 163.2 kilojoule per mole. This much answer is coming.
Log of 2.47 minus.
Temperature also you need to keep. No?
Yes, times 298, so negative. Negative 8.31 times 298 times log
0.396. It will be multiplied minus 29. So see, minus and minus, it is going to be plus. So you said that is plus, minus, that is the impossible. It will not come plus because here is negative and here is the front is negative. So it is coming positive. Now let us try to multiply this all the value.
Okay, I got the answer. I forgot to multiply by 2.303.
Okay. So the same answer is coming. No?
Yeah.
Thank you. So what I'm going to do, let me check any other problems if I can give you. Wait a moment. Not there in this. Finding the problem. So now this is enthalpy. There is also okay. Where is enthalpy? This is also enthalpy. Okay. So let us. I got the answer problem under Gibbs free energy. One more I am having this. Yeah, but it's very easy. What to give you to solve this. Very simple problems are there now for you. I didn't find the tough problem, so easy problem only I'm giving you. That is NH3 is there and it is reacting 2O2, so it is giving that is HNO3 plus it is H2O. So they are asking, they have given some of the data they have given. Okay, what the data? The third question. Let me see the data. Okay, this is the first one. Okay, and B number they are talking about Ca plus Cl2. This is they are talking about CaCl2. C number they are talking about HgO. It is converting it to Hg plus half O2. Like that they are taking. They are saying find delta G naught and predict which are spontaneous. They are talking spontaneous, which are spontaneous, and value they have given delta G naught for delta G naught in kilojoule. Delta G naught they have given delta G naught in what that is kilojoule per mole they have given. So that you keep in mind. That is they are talking about CaCl2. How much there? Minus 748.1. Second one is the HgO. It is given minus 58.84. And NH3, if you are talking about NH3, it is going to be 16.45. And HNO3, if you are talking about, it is going minus 80.71. And last one is we are having H2O. It is given minus 237.13. They are given. So you can be see delta G naught they are asking, and product and reactant value they have given. So what we have to predict this one. So we can apply that is delta G naught is equal to delta G naught product minus delta G naught reactant. Yes or no?
Yes.
Can you check that one? Anyone you can try. CaCl2 minus
Okay.
748.1, HgO minus 58.84, NH3 minus 16.4845. That is correct. Last one, HNO3 minus 80.71, H2O minus 237.13. That is all correct. Can I try, or you are going to try by your own?
I will. I'll try the first one, and if I get it right, then I'll just try the rest of
Yeah,
them.
yes, please.
So it's nothing negative 80.71 plus negative H2 is negative 37.13 plus NH3, which is negative 16.4. So the answer will for the first one will be negative 334.29, and it is spontaneous.
Yeah, spontaneous is correct, but they are saying that the answer is minus 301.39. Like that they have mentioned.
301.39. HNO3 is negative 80.7, and then negative 237.13. And then is NH3 16.45?
Yeah. But okay, you got a negative of around 300. That is okay. Leave it. It
Okay.
may be correct only because the calculation may be something up and down. No problem. So you got to know this method. Okay. So can we go for the enthalpy problem? Some of the problem can we solve on the enthalpy? Other two questions can you do later on, or now you want to do?
I can do them later on whenever is fine.
Okay, very good. So let us try to go for the enthalpy. Can I erase this one?
Yeah.
So, okay. If we talk about enthalpy, can you define what do you mean by enthalpy? What is it?
Enthalpy is like the randomness of a system.
Entropy is randomness of the
Oh,
system.
entropy, sorry.
I'm asking
Uh,
enthalpy.
Enthalpy is, I think, it has something to do with like the energy, like the internal energy of a system.
Yeah, good, correct only. But, okay. If you define the enthalpy, there is a very big term. But in the short way, if you define enthalpy, it is change in energy. They are talking about in the change in energy, and change in energy means in the term that is either absorb or loss. Either they are talking about either absorb, they are talking either absorb or that is released. Okay, so
Mhm.
energy either absorb or release. For both the term absorb and release, both the term we are using that is enthalpy. Earlier time we were using the energy are supposed to be the absorb release only they were talking about, but nowadays we are using the term enthalpy, and enthalpy is also having the three convention. So that is enthalpy delta H naught if you are writing. So if suppose it is coming the positive, so positive means they are talking about it is going to be endothermic. Okay, endothermic. Endothermic, that is what you can say energy absorbed.
Okay.
Energy going to be absorbed, right? Energy absorbed. Now the second one, if you are going, that is negative. So that is exothermic. Negative means going to be exothermic. Exothermic, that is energy release. It is going to be energy is going to be released. This is the point. And the last one, they are if it is zero, that is also they said that is equilibrium condition. Equilibrium. And equilibrium condition, that is neither absorb nor release. You can say neither absorb nor release.
Mhm.
Neither absorb nor release. This is what the case is for this one, right? Now formula, if you are talking about formula,
Mhm.
there are so many formula are there. I'll go one by one. Okay. So formula one, if you are talking about delta H not is equal to delta H, this is going to be product, okay, minus delta H not reactant, okay, that is H not reactant. This is the first one. Okay, already you solve one of the some of the problem, but what we are going to do, we are going for to solve some more problem. So can I give you the problem based on it?
Yeah.
Okay, thank you. But enthalpy are there in the so many forms are there for the enthalpy. Here that is enthalpy is calculated for 1 mole. It is for 1 mole. It is for 1 mole. When you talk about the enthalpy is always calculated for 1 mole. So I am changing. Can I change this one? Can I change?
Yes.
Yeah, next page. Okay. This type of problem, what the enthalpy problem, it is given in your book. Okay, the similar question I'm giving you from, this is I think from your book, I didn't mention here. Let me try to write the question. They are saying the oh, wait a moment, please. CO2. Oh, I didn't do anything here. No? Okay, let's do product minus reactant, same one. They are talking about the delta H naught for CO is minus 390 kilojoule per mole, and they are saying no, carbon, not CO, it is the carbon, and they are talking about, and CO is minus 278 kilojoule per mole, right, respectively. See, very tough problem. They are saying find the enthalpy of formation of CO2. Find the enthalpy of formation of CO2. Enthalpy of formation. Enthalpy of formation of CO2. Yeah. See. So here they wrote, that is what they wrote, the term in bracket, combustion they have wrote, combustion. They are doing combustion. And here also they wrote that is combustion. So how tough this problem is, we can see the solution. Let me try. That is C plus O2. They are burning, so they are giving CO2. For this value 390 they have given. Okay, and then CO plus, it is going to be half O2. So they again they are going to give CO2, and here they are going to give the value. Okay, how much? 278. This much they have given, but they are asking that is enthalpy of formation of the CO2 they are asking, right? So that's okay. See the required reaction, but for enthalpy of formation of CO2, the from first reaction also we are getting CO2, and second reaction also we are getting CO2, but everything is not required. How much required for 1 mole? So required reaction I am asking. If I am asking a required reaction, so required reaction means C plus O2. Okay, there, find the enthalpy of carbon monoxide. Sorry, enthalpy of formation of carbon monoxide. I did mistake. Formation of carbon monoxide. The enthalpy of combustion of carbon and carbon monoxide are 390 and minus 278. The enthalpy of formation of carbon monoxide. So carbon monoxide means C plus half O2, it is going to be CO. For this reaction, they are asking that is enthalpy of formation, this one. But here CO2 are coming. What can we do? This is the required reaction. So if you solve from this data, the data are this only. So what we are going to do, we are just reversing. See, if I will reverse this equation, so CO will come in the product side, because here they are asking enthalpy of formation of CO, not CO2. So can we reverse this second equation?
Yes.
Only if we reverse, then only we are going to get anything. Otherwise this way not possible. So that is C plus O2, that is here is the CO2, no problem. Here is what we can write, CO2 equal to CO plus half O2. Yes or no? So
Yeah.
now see, the first reaction is as it is, 390 as it is. The second reaction, it is 278. So we reverse, so the sign also going to be reversed. Now, what we are going to do, let us cut out. Here cancel, this is also cancel. Getting, yes or no? So that is cancelled out. CO2 is cancelled out. Now you solve it out. Here is half O2 is there, half O2, and here is what is there, how much is there, you can see 1. So if I will subtract half, so it will have, that will be half O2, and it is going to be what, CO. C plus half O2 is equal to CO. Yes or no? So this is C plus half O2 CO. So for this one, what we are going to do, enthalpy of reaction. Enthalpy of reaction, if you are talking about, so delta H naught product minus reactant. So enthalpy of reaction, you see, so what will be there? No, H naught for this reaction. What can we? How can we write? Delta H naught is equal to product minus reactant. So here you see product. So what we can do here? This value they have given. This value they have given. So delta H value. For 1 mole formation, they are saying that is add this value, add these two datas. So here they are talking about delta H naught, because what we did here, after adding these two reaction, we got this one now. So enthalpy of formation, what we did, we need to add this one. So enthalpy of formation, it is the thinking base. Okay, critical thinking question, critical thinking. If I will apply the formula, we might not get the answer, because if you want to, delta H is equal to what? Delta H product minus delta H reactant. Delta H reactant. Here is the product. If you are talking about delta H product is equal to delta H not reaction minus delta H not reactant should come. Of delta H not reaction, they didn't give anything information. Okay, what is there if you are talking about the reaction? So minus 390, and here it is going to be 278, because reactant side. Little bit it is getting confusion. Sorry, if you are applying what I am saying, if you are applying this formula, it may be little bit confusing to you. Okay, because you see, enthalpy of reaction, what are the value? C plus half O2 CO2 and CO plus half O2, both are the reaction, so it is very difficult to apply. So one more is their critical thinking problem, that is for 1 mole of formation of, say, like, please try to understand, apply your mind, na? For
Yes, yes.
1 mole,
I.
for 1 mole of CO2, for 1 mole of CO formation, what you did? Firstly, you see C plus O2, that is CO2, and second one you this CO2 plus CO2 is giving CO plus half O2. So while adding these two equation, you are getting CO. Yes or no? By adding these two equation, you got CO. That firstly you make it clear,
Yeah.
that is by adding these two equations. So if you are by adding, you are getting CO, means that whatever the enthalpy release or absorb in the both the equation, that will be what the enthalpy of formation of CO. Yes or no? Again you try, again you try. Can I explain now? Hello, audible? Audible? Sorry, audible? Hello, sound is, hello. Hello.
My Wi-Fi went out, sorry. But I think so. From what I understand is that we just have this is like kind of like Hess's law, right?
Yes, 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 yes. This is Hessla only. Oh, you understood, na?
So if we use Hess law, we can find the delta. Yeah,
Huh. So if you are applying this means we have to add this one. So enthalpy of reaction will be what delta if you are talking about delta H naught CO. So by adding these two equation we got na CO. Yes, yeah, no.
yeah,
So we are adding this
yes.
one. So what is 390 plus 278? So something is going to be giving 112 kilojoule per mole. Can you be able to
Hmm.
understand this one?
Yeah, I understood this now. After I made the Hess's law connection, I
Ah,
got it.
so it is all about the Hessla. So can I give you the problem based on the this one? Hessla, you know, na?
Sure. Yeah.
Okay. Uh, please wait a moment. Let me find out the problem. Uh, so I am giving you the problem based on the Hessla only. Hmm, this is not this you already did. Okay, I got the problem. So let me write the. Can I erase this one?
Yeah.
Okay. But this type of problem is quite critical for the average student face the problem. So calculate, they are talking about calculate, okay, enthalpy of formation of what they are talking about, enthalpy of formation of CH4, okay, from following equation. They are talking about from following equation. They are talking about following equation. So what the equation they have given, C plus O2, they are going to be CO2. For this one, they have given minus 393.5. And here they are talking about H2 plus half O2. How much they are talking about H2O? Here is minus 285.8. And here is the CH4 plus 2O2. They are talking about CO2 and plus 2H2O. Here is minus 890.3. They all are the kilojoule per mole. So enthalpy of formation they are asking Hessla. So
Hmm.
options, I am going to write the option. You try the answers.
Yeah.
Yeah, option.
CH4. Three. Hmm, okay. CO2 and I'm getting a C negative, oh sorry, A negative 74.8.
Yeah. So you are solving like anything. You are able to understand this one. Okay, so what else in this chapter are there? Everything you know. What
I
else should
think
I do?
everything we've covered.
Yeah. Uh, everything you actually what I covered very little things. You know, whatever I taught, you know, very much you are coping nicely. So
Mhm.
whatever the problem I am finding with my book, some problem was of course are there, but that also you will be able to solve. Like that, what the problem they have done, the values they have put it that is critical, like 3267, like that. The value only they have kept
Mhm.
more. Other things are the same. I'm giving you one problem. Let us see how the I have selected from the that is AP book, not from your some other book I have selected. So I probably IB book. Okay, IB book. This is okay. So see they are saying the what they are talking about. The combustion of 1 mole of benzene takes place at 298 Kelvin. After, yeah. Okay, see, I'm writing the combustion of, we are talking about the combustion of 1 mole of benzene C6H6 at 298 Kelvin. At 298 Kelvin gives there's and 1 atm they are talking at 1 atm gives what they are talking gives CO2 and H2O to to release, we are talking CO2 and H2O to release how much? Minus 3267 kilojoule of heat, okay, produced. 3267 kilojoule of heat produced. Okay, produced. Then they are saying what they are saying. Calculate the standard enthalpy of formation of benzene. So they are asking some different. Calculate the delta H naught benzene C6H6 standard formation of benzene. Uh, if enthalpy of formation, enthalpy of formation of what they are talking, enthalpy of formation of, they are talking about CO2 and H2O are, they are talking about minus 393.5 and minus 285.83. 285.83. They all are in the kilojoule per mole, right? So equation also they have given C6 H6 plus 15 by 2 O2, and here is 6 CO2 plus 3 H2O they have given. So see how can you do? So if you are talking about enthalpy of reaction, okay, so delta enthalpy of reaction means we need to add enthalpy of reaction, na? Delta H naught here. So that is going to be product minus reactant, yes or no? Delta H naught is equal to delta H product, yes no Solia? Product minus reactant,
Mhm.
product delta H naught reactant. This I am putting. See. So enthalpy of reaction, they have the combustion of 1 mole of C6H6 at 1 atm gives CO2H2O to release this much. Enthalpy of reaction they have given how much? Minus 3267 is equal to enthalpy of product if you are writing. So it is the 6 CO2 plus 3 H2O minus enthalpy of reactant. For this value, enthalpy will be 0, standard enthalpy, natural state. And that is, it is coming what? C6H6. So here value they have given minus 3267 is equal to 6 into CO2. CO2 they have given how much? Minus 393.5 plus 3 in water they have given 285.8. So minus C6H6. Okay. So can you be able to solve this one? Now this all, after solving, what will happen? This all the datas will go that side, yes or no?
Yes.
So that is if you are talking about delta H and not C6H6, how much is coming? They have given minus 48.5, 48.5 kilojoule per mole. This is our answer.
Okay,
Okay.
got it.
So like this problem are also given, but you will be able to solve easily. That is why I'm not going to give you
Yeah.
many of the problem. So next chapter, whichever you will study, you tell to sir, na?
Yes, next chapter will be electrochemistry. We'll start from next week.
Okay. So for that, you kindly either send to sir or the mail to me.
Sir, can I email you the notes? Because sending it to sir and then sir takes some time to send it to you. I'll just
Ah,
email the notes to you and
thank you very
okay.
much. Sir, send at the like that. Suppose na class today is there na. So today morning he will send like that 10 o'clock, 11 o'clock. I never get the time to see because I am not dealing the AP curriculum. I am dealing here in India CBSE
Right, right.
curriculum. Different curriculum. So
So
or
I
the
have the electrochemistry notes right now only through email.
yes, sir. Please you send me, please. Thank you very much. So we'll be studying electrochemistry in the next Sunday.
Okay,
Yes,
thank
yeah.
you, sir.
Okay, welcome. Bye, Surya. Bye.
Yes, thank you.